Chris and I host these monthly webinars, always on the third Monday in each month. And we always have guest speakers joining us. And so we have two speakers today as well. And I'm going to introduce them here in just a second. Just to start with, maybe quick introduction for those of you who might be joining us for the first time. My name is Antje. I work as a developer advocate at AWS, focusing on AI/ML, and I'm joining you from Düsseldorf, Germany. Chris, do you want to briefly introduce yourself as well?
Sure. Yeah, I'm Chris Fregley, Principal Developer Advocate for AWS in AI and Machine Learning, co-author of the Data Science on AWS book Antje is showing here. That was just released. Quick plug for that. We shattered our 1 month sales, exceeded the expectations for the entire lifetime of this book. So we're very proud of it. 500 pages, pretty much everything Antje and I know on this topic, and big data and machine learning and data science in production. So I'm based out of San Francisco, and back to you, Antje.
Yes, thanks so much, Chris. So I'll post here, and Chris, maybe you can have a look at the Slack channel as well, if there's any questions coming in, and repost links. So yeah, as Chris said, we're super excited. The book is out, is available. And I think just today, I looked it up here, we're actually #1 new release in cloud computing as well. So that one just came in today, fresh. So we're super excited. If you're already reading the book, we would also love to see reviews. So if you like it, feel free to also drop us a review here on Amazon. All right, and with that, I'll start introducing our guest speakers for today. So I'm excited. We have two speakers, and the first speaker is Philipp Schmid, and Philipp is a machine learning engineer at HuggingFace. So if you followed our webinars or even joined us for the monthly workshops we're running, we're working a lot with the HuggingFace NLP library, and we're super excited also to have Philipp today presenting some new integrations. So he will show us distributed GPU training using the HuggingFace transformers and Amazon SageMaker integration. So super excited for this talk. And then we also have Dr. Zhang today here. He's a principal product manager for SageMaker JumpStart at AWS. And he will give the second talk and introduce you to the SageMaker JumpStart service, and also give you a nice demo of all of the goodness, what you can do there. You have access to pre-built models, text models, vision models, etc., in popular model zoos, and also a broad range of end-to-end solutions that you can deploy through JumpStart. So also I'm super excited to see what's new there. All right, and with that, I'll stop my screen share and hand over to Philipp, who will take the stage here for the first talk. Thanks for joining us today, Philipp. And you have to unmute.
Hi, everyone.
Yeah, perfect.
Yeah, perfect. So, hi, everyone. I'm Philipp, and I'm glad to be here today. And I would give you some experience on how to train this, how to distribute train using the Transformers library and SageMaker. And I preferred a short agenda. In the beginning, I would talk about the HuggingFace as a company, then the HuggingFace ecosystem consisting out of the many open source libraries we have nowadays, then the partnership we started with AWS in March, and then at the end I will do some hands-on on how to train a Transformers model on SageMaker using data parallelism. To me, I'm a machine learning engineer and tech lead for the AWS partnership. I'm also from Germany, but I'm from Nuremberg. It's in Bavaria, so a bit south from Antje. And I'm on Twitter, LinkedIn, and there's my email address. I expect that Chris will share with you the presentation after the meetup. So if you have any questions, feel free to reach out to me on any of these social medias. So the main goal from HuggingFace is to democratize NLP. And for us, this means we want to make NLP accessible to everyone. We want to have everyone be capable of using the latest state-of-the-art transformer models, give everyone the ability to contribute to the greater goal, to make it easy for every person around the world to use the latest and greatest models. And how we are going to do that? So first of all, it should be easy to access the models and try these out. Therefore, we created the hub, as you can see here. And in addition to this, we created several open source libraries like transformers you're probably familiar with data sets where you can easily load NLP data sets, then the tokenizers library, which is used to convert your human readable text into machine understandable text or data basically. And we can all do this with not alone. So we have a large community with now over 840 contributors to the transformers library. And in total, we have over 1,000 open source contributor to all open source libraries we have. And transformers is one of the fastest growing libraries on GitHub. As you can see on the right, there are a few pretty famous compared projects like Apache Spark or MongoDB who haven't grown that fast than we, and hopefully we can get to 50K stars by the end of the month. And Transformers is not, or HuggingFace is not only open source, so a lot of companies are already using Transformers in production use case. A few examples have I listed here out, like Monzo is using it for text classification to determine the sentiment from customer feedback. Then Bing from Microsoft is using transformers for question answering in their Bing search. Bloomberg is either generating text out of business informations. Then we have Square using it for a conversational use case. So transformers and the BERT models are basically now in every area of business, I would say. Then the ecosystem, as I already have shared with you, that the ecosystem mostly, or the building blocks for our ecosystem are the transformers library and the tokenizers library. The tokenizers library is used to convert text to tokens and then to IDs to use them to train your models. And the transformers library makes it easy for you to train the latest and greatest architectures from Google and Facebook with your data. And we also have the trainer API inside transformers, which makes it even easier to train these models, where you just need to provide your data set. Then you can define your hyperparameters, create a trainer class instance with your model you want to choose to train your hyperparameters, add in your data sets, and then you can call trainer.train, which is pretty identical to what you can do, for example, in Keras with your model.fit method. So that's pretty nice. So you don't need to write these complex custom training loops for these transformers models. Then, as we have already talked about, we have the model and dataset hub. And the model hub is the central repository for all models across different frameworks. So it has grown above transformers. We don't have only transformer models there. So for example, we have models from LNNLP, which also is an NLP library, from Flare, which is another NLP library. And with the latest release of Transformers 4.6, we have out the first image models from TIM and from with vision transformers. And there are also models from speech. So you can find over 11,000 different models of the topics from NLP, vision, and speech on the Model Hub, and every of these are free to use. So you can click in, try the widget we have there, and then if you feel good about using a model or fine-tuning it, you can easily download it with like 2 lines of code and use it for your use case. So that's pretty awesome, I would say. In addition to the Model Hub, we have the Datasets Hub, which is, I think pretty new, with now over 1,000 different NLP data sets. where you can load basically with one line of code your data set for a classification, for question answering, for summarization. It includes pretty popular data sets for benchmarks like Squat or Clue. So we basically, firstly, we lower the bar to train your transformer models with the transformers library. And then with the model hub, you have these model accessible. And now with the datasets hub and the datasets library, you can use a huge amount of different datasets to train on, to train your model. So that's pretty amazing. Then our basically latest and two newest libraries are Accelerate and NN Pruning. Accelerate is more focused for research and science, I would say. Accelerate abstracts all the configuration you need to run on different environments. So you, as you can see on the code snippet here, you initialize Accelerate, and Accelerate will handle all the device placements, the optimizer and the data loader. But you still have the freedom to create to write your own custom training loop. So with Accelerate, you can create your training loop and run it on any environment you want. So for example, if you want to start prototyping on a small single GPU, you can create your Accelerate script with your custom PyTorch training loop. And then when you have a good feeling, you can scale it up on multi-GPU, on multi-node, multi-GPU, or even on TPU without changing a single line of code. And the other library is NN Pruning, which is a library around block movement pruning. With this, we are trying to optimize the transformer models even more with up to 2 to 3.5 speed up and pruning 60 to 90% of the model weight. So we are making the models smaller and faster and keeping nearly the same amount on precision as you have with the normal model. For example, if you can see here, the upper vertical orange line is from a bird base, and with for example the if with 80.8, and the first I would say pink line is a hybrid field with a bird large teacher, where we achieved a speed up of 2.5%, keeping the same result as bird base, which is pretty amazing. And we put a lot of effort into this pruning library to make these models more accessible and to run it faster and on smaller hardware. Then our last building block is the inference API. Since you have now trained your models, have the models available on the hub, you want to use them in production use case. And therefore we created the inference API, which is basically, or which can take each model from the hub. So each of the 11,000 models you have on the model hub can be used with the inference API. And it's a REST API where you can pass in the model you want to use and then send an HTTP request to the model and are ready to use. And it's super easy. So if you are creating a new model, uploading it to the hub, after a few minutes, it's available in the inference API and you can use it. So if you have a data science team which is creating these nice models for your company, then they can upload them to the hub, either private or public, and your engineering team can use the inference API, use the new model without any pipeline in between, without any deployment in between, and you can basically switch to production in like no time. And to make training easier, we have a new service called AutoNLP, which is currently in beta, which is with the idea to automate machine learning for NLP, therefore AutoNLP. And AutoNLP currently offers a CLI where you only need to define which task you want to train on, pass in your data, and then you can start your training and get basically the best model for your data set on the current technology and architectures we have. And at the end, it will be uploaded to the model hub as a private model, and you can directly use it for inference with the inference API. So you can now create state-of-the-art models with only 3 lines of code, and you only need data to get basically the same performance as Google and Facebook. Then to make it complete, the ecosystem is basically these 5 different services with the model hub, tokenizers, and transformers, and all the different ones. And as you can see, it's each service is pretty connected to each other's service. So the goal is to make a nice system which is developer friendly and easy to use, from training your model with pre-processing your data sets until you want to deploy it or use it for inference. And therefore we established this partnership with Amazon SageMaker in March, with the goal to make it even easier for companies to leverage state-of-the-art machine learning models. So we have seen training is pretty easy with the trainer API or with transformers, but you still need underlying infrastructure and hardware to train these models. And transformers are not small models you can train on your laptop or on your small PC. You need heavy machines behind it, and AWS offers like these heavy machines without any issues. You just need to click a button and then you have like 100 different GPUs if you want, for example. And within this partnership, we have created new deep learning containers. So if you are not familiar with Amazon SageMaker at all, Amazon SageMaker or AWS has something called deep learning containers, which are Docker containers optimized for deep learning for different frameworks. So before there were deep learning containers for MXNet, for TensorFlow, for PyTorch, and we have created a new deep learning container for the HuggingFace libraries for PyTorch and TensorFlow. So we try to optimize the transformers library for AWS to use the latest and greatest libraries, like the data parallelism library announced at reInvent 2020 last December, also the model parallelism library. In addition to this deep learning container, we extended the Python SageMaker SDK to make it super easy to start these kinds of training jobs using the HuggingFace deep learning container. And we also created different amount QuickStarts, an example to help you get started with SageMaker and transformers. So there are examples for using PyTorch or using TensorFlow, and how can I train my model in the data parallel way? How can I train my model in the model parallel way? How can I save costs with using spot instance? Or how can I track my metrics of the model? So there are a lot of examples out there. Then how you can train it. So basically you need to import the new HuggingFace estimator from the SageMaker SDK. There you can define all the important parameters you need, like your training script, the instance types you want to run on, the instant number you want to run on, and then you can call the estimator.fit method, and the SDK will then start your training on SageMaker. And what is super cool about it is in the transformers repository, we have a directory for examples for each of the NLP tasks out there, like text classification, question answering, and each of these scripts is compatible with Amazon SageMaker and the SageMaker SDK. We will later use one of these example scripts to run our training on SageMaker with like 10 lines of code. And to make it even more easier for distributed training, we integrated the SageMaker data parallelism library and the model parallelism library into our trainer API. So if you are using the trainer API, as I've shown before, for training your transformer model, you only need to provide the configuration in your estimator, and transformers will figure out itself if I need to train on multiple GPUs or multiple instances and multiple GPUs, and if I'm distributing my data or my model across these instances. So you need to define like this one line of code with SM distributed in it, and you can train on multiple GPUs in SageMaker, which is pretty nice. Are there questions already before we go into the hands-on example?
We do have a few questions here, but as you like, if you want to answer them after the demo or right now, up to you, Philipp.
Yeah, I think we can answer them right now, and then if there are some more, we can answer them after the demo.
All right, so the first question came in, what is your opinion on bigger is better for NLP models?
I mean, it depends on what you want to do. I think bigger is better. With bigger is better, you achieve better results on the benchmark, but bigger is better is not usable for a company. So, for example, if you think about GPT-3, which is around, I think, between 400 and 500 gigabytes, no normal company can use it in a production environment. So that's why we focused on distillation, for example, with Distilbert or with NN pruning to use these big models, create smaller, efficient versions out of it for a company to use it. So I think it depends on what you want to do in which environment you are.
All right. Perfect. And then we had one question specifically for healthcare data. So do you know of any examples how HuggingFace models can be used, or if you know of any use cases maybe that are already in place used in healthcare unstructured data to infer entities, and a follow-up like alongside with the Amazon Comprehend service? But maybe, yeah, you can tackle the HuggingFace part.
Yeah, so for example, there are multiple already pre-trained models on the hub for healthcare and science data. And there is also a named entity model. So if you are interested in it, I definitely suggest you to go to the huggingface.co/model site, use the search for like medical or health. Then you find already a few examples where you can try. Maybe you have some data you think is you want to try to prototype on it. And we also have models around zero-shot classification where you can use where you can use a trained model and your data to run zero-shot classification on it and get a feeling on, okay, is it worth fine-tuning a model on my data or not?
Yes,
and compared to Comprehend, what was the question again?
Yeah, if it's like compared or alongside with Amazon Comprehend service. So,
I think it depends again. I mean, with Comprehend, I think you can also have like your custom data, and Comprehend then trains on your data. And if you use the managed service from Comprehend, I think you have a few different NLP tasks there too. But I think the big difference between Comprehend and HuggingFace is that HuggingFace is completely transparent. So if you find a model on the hub for let's say sentiment analysis, you know which model you use, you know the author behind the model. There's normally always a model card which explains how the model was trained, on which data it was evaluated. But I think Comprehend can give you a short head start if you want to use it now. And Comprehend is pretty good integrated into, for example, AWS Amplify if you want to build a mobile app. But on the other hand, you can use the HuggingFace models, and we have a lot of them for each of these tasks. I think we have over 160 different languages, and for all of the I think most spoken language like Spanish, English, German, Italian, Portuguese, Chinese, there are models for each of the default NLP tasks you can use. And I will go into the model hub in a second. I can show you how easily you can test them without the need to spend any money on let's say a service on AWS.
All right, yeah, let's maybe just to add to that. So Comprehend actually also comes with a Comprehend medical version, so which is pre-trained specifically on healthcare medical data, if folks are interested. All right, let's maybe jump into the demo. And I have a few questions on the auto NLP, but let's first do the demo.
Okay, so in the demo, we will completely start from scratch training a model on distributed data. And I'm currently on the HuggingFace hub. And as we have seen a screenshot, and I can go to models. And here you can find each of the model where you want to train on. And last week, we added a new feature to the hub. When you go to a model page, you have like the model card, as I've described. You have the widget where you can test a model on data. So currently we are on the Distilbert model, which is a distillated version from BERT. And with the basically full mask or mask language model task you can test on. And we added this new use in SageMaker button where you can click on, select the task you want to train your model on. For example, if you want to train a model on question answering, you select question answering, then you select your configuration, where it is either AWS, meaning if you are starting your training job in AWS on either a SageMaker notebook instance or inside the SageMaker Studio, or if you want to start your training from your local machine. Selecting AWS will create a snippet. Selecting local machine will also create a snippet, but add a few more lines of code since the permission handling is different than in AWS. But we will use from AWS, and then you get the snippet with the task we selected. And as I have already said, we have scripts for each NLP task on our or in our repository, so that way we can provide these scripts for the task. Then we can copy it, and I have started a SageMaker notebook instance where we create a new kernel on PyTorch. Paste in our code we copied, and what we have created is we have a call which selects basically the IAM role we are going to use inside our SageMaker jobs, defining if our SageMaker training job is allowed, for example, to load data from S3 or to sync data to EFS. Then we have our hyperparameters. By default, we have the model name defined and the output by directory where the model will be saved after training. This is pointing to the default model directory from SageMaker, so it will be uploaded at the end to S3. And then you are free to add like the remaining hyperparameters you want to use. Therefore, I prepared some. I added a data set, the squad one for question answering to make it easy for us. This data set is available on our dataset hub, so I can use it with the dataset name. We want to do training, we want to do evaluation. I define a per device batch size, meaning that is not our total maximum batch size, it's the batch size for each GPU we are going to use. Then we are training one epoch, we have a max sequence length of 384, we have a doc stride of 28, then we are going to use mixed precision to make our training faster and pad to the max length of our sequence. Then the next line is the Git configuration, which helps us to use the scripts we have inside the Transformers library. So this basically preloads the Transformers repository and provides the script. And then we have the HuggingFace estimator with our script, the location of it, the instance type, the instance count, our role we have defined above, the Git config, and then which version of Transformers we want to use. We want to use the 4.4.2 version with PyTorch backed, and then the Python version. But since we want to use distributed training, so if I would execute this, I would train on the P3 instance, a single GPU with these hyperparameters. But we want to train on distributed training, so therefore we add the distributed configuration, and in our estimator we change the instance type to the P3DN24X large, which has 8 GPUs, 8 NVIDIA V100, I think. We have our distributed configuration, and we want to run on 2 instances. So basically we have a multi-node, multi-GPU setup. And if I execute the cell, it should show us in a second that our training job is started. Yeah, starting the training job. This will take around 5 to 10 minutes. I have done exact the same thing before the meetup. And at the end, you can see we have our train second, we have the logs, the output. We have the last thing output was the evaluation score with an F1 of 77, which is, I think, pretty good for only training on 1 epoch. And then what I have done is I installed Transformers and PyTorch 1.6 so we can test the model. Therefore, I've created a small little script which loads the model file from S3. So at the end of our training, the model was saved to S3 to use it for inference or to do whatever you want with it. I'm loading it from there, unzipping it, and then I'm using the transformers pipeline for question answering. And I prepared in context from Antjes and Chris' book with a question: who are the authors of the book? And if I executed the model we are training, will predict that the book is written from Chris and from Antje. Yeah, that's basically it. I think it took around 5 minutes to start our training on multiple GPUs and multiple nodes with defining a few hyperparameters. And I think we can wait a bit more to see the training starting and answer a few more questions.
Brilliant. I love it, Philipp. Nice demo. We got a few questions coming in here. How to choose between the TensorFlow and PyTorch model if I have like for the same model type? I assume it's going towards the naming convention, but the attendee who asked if you could clarify if that's the question exactly.
Sorry, what was the question again?
How to choose between the PyTorch and the TensorFlow version of the same model? How do I select it?
I think it depends on what you want to use. So if your company or you are pretty familiar with using TensorFlow and writing your training script in TensorFlow, then go ahead and use TensorFlow. If you are pretty familiar with PyTorch, then go ahead with PyTorch. Currently, the trainer API, which is only available in PyTorch, supports the distributed mechanism, but we are working on the same integration for TensorFlow, or rather Keras. And I think personally, I would always go with PyTorch because it is a bit faster by default than TensorFlow. But if you then optimize your training loop for TensorFlow, it's kind of the same.
Okay, yeah, and I see here the follow-up clarification because there are different implementations of the same model in HuggingFace. So full support for PyTorch, yeah. And then I think the naming convention is still, Philipp, that you call the TensorFlow models are starting with a TF, right?
Yeah. So if you for example, if you want to use the pipeline with TensorFlow, you have the TF auto model from question answering.
Yeah, perfect. Yeah, exactly. Let me see here. Question coming in. A personal question for you. So if you wanna maybe briefly just answer, which path has led you from the university to working at HuggingFace? In your opinion, which skills are important for a machine learning engineer apart from knowing the common frameworks? And maybe that's also one to take offline, but if there are any internships at HuggingFace. So maybe you want to shortly touch, yeah.
Yeah, if someone is interested in working at HuggingFace or an internship on angel.co, we have a lot of jobs open. We are hiring currently, so we have raised our Series B in March too, and we are looking for basically any position you can imagine, and feel free to apply there. And for me, my personal path, or what I definitely would suggest, that if you have passion in machine learning or NLP in general, share it and show it with the community. So for example, I got to HuggingFace because I started a blog like 1.5 years ago, where I have done a lot of work using HuggingFace and transformers, started to create pull requests against transformers and dataset, and just shared with the community. And that's how I got in touch with all the people there.
Perfect, yeah. And I suggest anyone who is interested maybe to follow up via Twitter or your preferred way directly. All right, one quick question. You did a pip install PyTorch in the notebook while also running the PyTorch kernel. I think people just wanted to know if there's a specific reason.
So as you have seen, or the model we trained is using PyTorch 1.6, and the current kernel uses PyTorch 1.4. So that's why I installed PyTorch 1.6 here too.
All right,
just perfect. To make sure everything works.
Yeah. All right, great. So in the interest of time, thank you very much, Philipp. If there's more questions coming in, maybe you can stick around and just check here in
Yeah,
the
I
chat.
also joined the Slack channel of Antti and Chris. So if you have any questions, you can tag me there with, I think, Philipp Schmid it is, and I'm happy to answer the questions there too.
Perfect. Thanks so much, Philipp. And
You're
with
welcome.
that, I'll hand over the stage to Lee, who will introduce us to SageMaker JumpStart next. All right, Lee, stage is yours. Maybe you can give a quick introduction of yourself and then take us through JumpStart.
Okay, yeah, thank you. Hello. I'm trying to share my screen. Can you see my screen?
Yes, we can see your PowerPoints. Yep.
This
perfect.
one, getting started with machine learning, can be challenging.
Yes.
Okay. Yeah, so a quick introduction. So my name is Lee Zhang. I'm the principal product manager for SageMaker JumpStart. SageMaker building algorithms, reinforcement learning, everything that relates to algorithms. I have my hands on it. So, please feel free to reach out to me. So given limited time, let me just quickly go into the meat of the presentation. So let's talk about JumpStart. So as the name indicates, we try to get everything, help you get started quickly. As the reason all you come is maybe because doing machine learning is not that easy. It takes time. It actually requires knowledge of both the cloud infrastructure as well as all the machine learning techniques, right? Into how do you build a model, train, deploy the models. So it's quite a lot of background knowledge that's needed. And the goal for JumpStart is to make it easy for you to get started quickly. You could be a beginning user, or you could be a very sophisticated, experienced user. Nothing will prevent you from, getting a quick start and getting the best tool available for you. So in JumpStart, we actually host right now 16 pre-built end-to-end solutions for common machine learning use cases. These solves business problems, covers from fraud detection, forecasting, predictive maintenance in many different areas. We actually also have over 100 open source models from TensorFlow Hub and PyTorch Hub, and give you a one-click deploy and a one-click fine-tune capability to help you get started using these models quickly. And we also host example notebooks to help, and blogs and videos to help you learn and how to use the SageMaker. So for the solutions, we cover these 9 big areas, and over time, we are enriching the number of solutions. And as you can see, it covers from both financial area to manufacturing area to demand forecasting, personalized recommendation, churn prediction. This covers a lot, and the application areas are in, I'm sorry, I should have turned off my my Slack. It covers there are vision algorithms being used to solve these problems. There are also many text NLP algorithms and models used to solve these problems as well. Now, for the open source models, we, as of now, cover 5 tasks in vision and text. In particular, they are image classification, object detection for vision, sentence pair classification, text classification, and question answering for text. Now, as all of you are aware, the development of machine learning and the models have accelerated so much that many of the open source models have wide applicability. So there are vision models trained on ImageNet, for example. They can help you detect, 1,000 different classes of photos. And it's quite applicable in the general domain. So these pre-trained model already can help you get started quickly. And we also added a fine-tune capability so that you can adapt these models to your own problem domain. So now this gives you only just a quick overview of the of what JumpStart has. Now let me go through share my screen and go through a demo so that you can have a better understanding of what it is JumpStart does for you. So a quick question. Can you see the change of sharing? Can you see the my browser
Yes,
window?
I see. Yeah, I see Studio right now. Yes.
Okay. Okay, great. Let me postpone, answer any questions until after this demo. So, given there is a limited time left. So this is SageMaker Studio, as probably all of you are familiar with. So this is the launcher page. Actually, being a product manager, I have the honor and opportunity to help design, shape the product. And in fact, these top 3 big cards are designed by me and implemented by my team. So these 3 cards, 2 of them to help you get started onto JumpStart with the pre-built solutions and with the pre-trained models. And the middle one is autopilot. Okay, so now to help you get started, now what is JumpStart? Like you saw before, we have pre-built end-to-end solutions. Now, what are they? Now, these solutions, all 16 of them, we can go quickly. Let's take a look at one. So for example, if you want to look at forecasting, so we have the, this search bar can help you identify contents from these over 200 types of models and algorithms. And here you can see that, let's look at deep demand forecasting. So here, with each of the end-to-end solutions, we actually help you solve a problem. In this particular case, it helps you to generate forecasts, predictions into a future. If you have, for example, a multi-dimensional time series. In this case, in this tabular format, we actually provide an example data set, which is an electricity consumption of 321 users over the period of 41 months. And we use this example data set. Now, we generate a prediction. We actually use a LSTNet deep learning neural network model to generate a prediction. Now, behind the scene, we also deploy a cloud formation template that tie the prediction, tie the training, pre-processing all together. And if you click launch behind the scene, these cloud formation templates are being deployed and they are managed by the service catalog. Now I have already deployed this solution. So now you can open and close the left side pane to see what has been deployed. Now you see I have done a lot. Being a product manager, I'm using these things on a daily basis. Now this already deployed demand forecasting solution. After that, we give you an example notebook. If you click, it will show you, oh, I already have one. That's open. Okay. This example notebook helps you walk through this solution end to end. It shows you how you copy the raw data to S3, how do you build a container for pre-processing and feature engineering, given that the multi-dimensional time series, all the numerical values are having different ranges. So the algorithm works better if you normalize all these dimensions. And then after pre-processing, you can prepare the, you can view the results, you can train the model with LSTnet on Gluon TS. It tells you how to set the hyperparameters and then fit the estimator to do the training. And after that, you look at the training result metrics. There are various mean square error, MAPE, all quantile loss, all different kind of training metrics that is being produced for you that you can study. And will also help you deploy an endpoint so that you can feed the new data to get the prediction. Now, at the end, you can also visually look at how the prediction looks like for different dimensions of your time series. So this tells you, all the other solutions are similarly constructed. So for example, detect malicious users and transactions. The architecture is a little more involved because it runs different built-in algorithms such as random cut forest and XGBoost on the transaction data to help you detect malicious users and transactions. And it involves AWS Lambda and the Kinesis Firehose. Once you click launch, all these whole architectures being deployed for you behind the scene. So it's much easy, saves you time to configure this. Now, this is so much about the solutions. Now let's go back to models we have. So we have 59 text models, and most of them are BERT-based. They help answer the 3 different types of tasks. And these models are from TensorFlow Hub and PyTorch Hub. If you click a card, what it allows you is you can do one-click deploy. You have the option to select a machine type or a default machine type is selected for you. So you can deploy this model to help solve a text classification problem. You can also fine-tune the model with a single click. We provide a default data set that you can see. This is the SST2 data set that we already put on the S3. Or if you have your own data set sitting on S3, we can help you browse and search and find your data set. After you configure your data set, you also have the option to set what type of machines you want to run it on, give the name of your model. You can also adjust some hyperparameters. We only set a small targeted set of hyperparameters so that you can start with, and then you can train. With one click of a button, this fine-tune of the model is run behind the scene. And for example, your training job can be visible here. And this is one of the training jobs I launched recently. And after you deploy an endpoint, all your deploy endpoints are here available for you. So I was doing some experimentation. There is one that was just deploying. And you can look at, for example, an ImageNet model. And you can look at, I run a ResNet, for example. After you deploy that, you can open a notebook. And here, this notebook helps you to learn how to make use of the endpoint. So how you download the example image for you. Let me see. Maybe let me just run it. What does it do? Okay, so I have a cat image. I have a dog image. Then I can run these 2 images through that endpoint. And then it's going to produce me, so for the cat, it says it's a Siamese cat. So it detects this is one kind of cat, and the dog is golden retriever. So with that, you already you can copy and paste this few lines of code so that you can make use of the model, make use of the endpoint for your own use. Now, I have opened so many tabs. Okay. So let's see. So for a BERT-based model, so for example, I have launched a BERT uncased model as an endpoint. We can look at what did I run? Maybe I already have, let's run it. So this shows you an example that this is a sentence pair classification. So I give you two text sentences. And what it says is, the first set is a positive. So it's astonishing, profound, this is all positive words. And the other is more negative. So these helps you to actually learn how to make use of all these deployed endpoints. I also have run, what else have I run? The dog and the cat. Oh, so here's another one. So after I deployed this pre-trained model, and it can recognize the cat. Tabby is one kind of cat with dark strips on the fur. But if I send a sunflower to it, actually the model wasn't that accurate. It says the inference result, the flower is daisy. So in fact, it's not a daisy. So what can happen is we can fine tune the model by a flower data set. So I actually deployed already, run the fine tuning. And then after I fine tune the model with a flower data set, I feed it deploy endpoint. And then what happens is the resulting fine tuned model recognizes sunflower properly. So this is another use case that you can, combine the fine tune and training and hosting together to help you answer questions in your own domain. Okay, so here, you have seen that how the solutions, end-to-end solutions work on top of CloudFormation template. You also seen how to deploy these pre-trained BERT model and pre-trained text models and also vision models. We have, for example, we have example notebooks to show you how to run XGBoost. And here it shows you this example notebook. You can click import a notebook, and then it will load a kernel. And here you can run the notebook. You can learn how to train XGBoost model, and how you set up a hosting, create an endpoint, and again how you use XGBoost to solve your machine learning problems. Okay. And further, we have blogs and video tutorials. How do you, do this?
Right,
you
welcome,
can see.
Everyone. My name is Ahmed Khan.
Okay. So these are the basic functions of SageMaker JumpStart. So we launched in December. We are continuing to improve JumpStart. And we are also adding more solutions and adding more ML tasks to help all the audience, all our users, to get started using doing machine learning quickly. So I guess this is it for my demo. So maybe we can turn around to answer some questions.
Yes. Sure. Thanks so much, Lee, for the demo and for the introduction here to SageMaker JumpStart. So we do have a few questions. Can customers add custom models to JumpStart as well, like to build an internal marketplace type of thing?
As of now, yeah, thank you for the question. So in fact, this is a great question. As of now, we do not have a customer contribution capability in this, but we have received a lot of feedback asking for this functionality. So this is something that we would like to develop in the future. Please get in touch with me, send me an email or Slack so that we can talk more about what exactly the type of things that you would like to have and what type of functions. I would be very interested in knowing from the audience, for example, what type of models do you have in mind that you would like to have, or how you would like to contribute?
Yes, so that's a good call out. Please share with us any feedback you might have. And also one more question. You showed briefly Gluon and Gluon TS in the beginning. So can you briefly explain what Gluon and Gluon TS is?
Oh, so yes. So in fact, the Amazon has a team that works on collection of machine learning algorithms, and they're called AutoGluon. So Gluon, Gluon TS, those are open source MXNet models that are built by Amazon. They provide, so in fact, if you do this, then this is the underlying AutoGluon type of models that we use in some of our solutions. So here it does probabilistic time series modeling. So it has a time series forecasting model. So we are just using that as an example to help demonstrate how to use, how to build a solution. Feel free to reach out to me. I can give you more context to the AutoGluon TS team. In fact, the team does more than just the time series forecasting. It has a lot of models on both vision, text, and some traditional machine learning algorithms in different, say, XGBoost, the Light GBM, many different models. So we are actually also using, we'll be including many of their models here, in addition to just TensorFlow Hub models and the PyTorch Hub models.
Perfect. Yeah, and people are asking how they can provide feedback. So you can join our Slack space and provide any feedback you might have, ideas, what you're missing, what you would like to see in the service. Feel free to share everything here in our Slack channel. All right. We also had a question on how to get started, if there's credits needed. So maybe I can take that question. So SageMaker supports the AWS free tier. So you can look up the free tier and then start exploring there. All right, and I think we're exactly on time. Thanks so much, Philipp, and thanks so much, Lee, for presenting today. And thanks everyone for joining us. Again, quick reminder, if you want to check out data science on aws.com, there's a link not only to the book, but also to the monthly workshops we're running. And of course, the webinars and code examples in our GitHub repo, and also a link to all of the recordings. So we also recorded today's session, and we will post the webinar in just probably a few hours, maybe a day, on data science on AWS at youtube.com. So feel free to check out that site, and you find all of the information there. And looking forward to seeing you hopefully in the next webinar. Thanks everyone for joining, and again.
Yeah, I'd like to add to everyone, I'd love to hear any feedback you can provide, and maybe through the Slack channel about our products, what new features you would like to see, what are the existing features that you think are useful for you, or you love solutions, or you love models, do you love NLP models or vision models? And do you have tabular data more, or do you have unstructured data? So please, feel free to actually send to us all these preferences, suggestions. We'd love to hear back from all of you.
We do.
Yeah.
All right.
Okay.
Thanks so much. Have a nice Monday, everyone.
Thank you, everyone.
Welcome. Bye.